Human error is a significant contributing factor in many equipment failures and maintenance-related incidents. Even well-designed systems can fail if maintenance tasks are performed incorrectly, skipped, or misunderstood. Managing human error is therefore critical to ensuring equipment reliability, safety, and performance. By identifying potential sources of error such as unclear procedures, inadequate training, poor communication, or fatigue, there are plenty of opportunities to make mistakes in aviation maintenance. Look at this easy example of one bolt with many nuts. This nut and bolt assembly can only be disassembled one way. However, there are over 40,000 combinations for reassembly, of which only one is correct. This is a good example of the complexity and chance of error in every maintenance environment. 80% of failure events are caused by human factors and human error. The aircraft and systems are improving. Reducing human error is one of the very last safety frontiers. There are many definitions of error, only a few of which are offered here. Generally, an error is an unsafe act unintentionally committed. In other words, we don't err on purpose. An error can be a slip or a mistake. Think about it. A slip is merely a good plan poorly executed. For example, you read a torque value from the job card and you transposed 26 to 62. A mistake is a bad plan. For example, you select the wrong work card to conduct a specific job. Much of the information on the card may not apply to the work task. A violation is a very serious mistake. A violation occurs when you deviate from safe practices, procedures, standards, or regulations. Slips, lapse in attention, the intention is correct, but the execution faulty. While thinking about a problem walk to where the workshop was 10 years ago. Mistake. Faulty ideas on what should be done. He thought it was the correct lubrication. How was I supposed to know that? Violations. Deliberate decision to ignore instructions. Stuff that I just do it this way / I add a bit more just to be sure. Managerial error. Poor policy. Unwise decisions. The human error rate table not only indicates the sort of issues that arise and the associated human error frequency that typically occurs, it also contains answers and solutions for the human error. Notice the headings for each of the 4 sections. The error rates falls as work goes from complicated to routine to simple to simplest. The message is clear. Make work and tasks simpler and errors decrease. You will also see the colored boxes. Compare the error rate on the right side to the left side. You can reduce error rate by making sure human eyes can easily resolve text and drawings, by using defined criteria during inspections, by providing visual confirmation via a drawing which choice and selection is correct. The table indicates that human error is unavoidable, but it can be reduced with sound and useful techniques. This table is an extract from the 7th edition of Reliability, Maintainability, and Risk by Dr. David Smith. It lists the typical error rates for a variety of tasks that equipment operators and maintainers do. You can see that some errors always occur. That is the nature of human beings. We are not perfect and we make mistakes. The table also shows that the frequency of making errors increases as tasks get more complicated and/or non-routine. The big concern for business and industry is when we start grouping individual tasks into procedures that belong to a job. The error rates for each task in the procedure multiply together and the risk to the achievement of the right outcome compounds. Let's see in the normal course of work what influenced the human error. Likelihood of human error. Human error is difficult to manage as people can do unexpected things. That is, the failure types are unpredictable. The likelihood of error increases when the stress on the person is excessive, stressed out, or inadequate boredom. The amount of information to process becomes greater or less than desirable. Decisions are made in haste. Unusual situations exist. People become entrapped by their habits. Task capture. The mental picture of the system is poor or the system is ill-defined. Poor training, ability/demand mismatch, poor feedback, or poor definition of roles and responsibilities. A task is considered unnecessary, or it is thought that errors will be fixed by others. Humans are limited by many factors that affect their perception and action at work. Merely select a few of them and talk about it. There are level 3 details for fatigue, anthropometrics and sensing, and perception examples. Clinical psychology deals with your psychological composure. It can address topics like emotions, motivation, fears, and such things. Anthropometrics is the study of factors such as size, strength, reach, and other dimensions that can be quantified to match the machine to the human. An original Coca-Cola bottle, for example, was designed to fit the average human hand, thus making it easy to hold the bottle and drink a lot of the product. Experimental psychology includes studying effects of stress on behavior and DOM-controlled studies of the effects of work policies and procedures. Computer scientists study the graphical user interface to be sure that humans can easily operate software. Therefore, computer science remains an excellent example of human factors. Cognitive science studies how humans think, how they solve problems, and the ways in which they process information. This knowledge can be critical to design of equipment, software, and documentation. Safety engineering applies to worker safety, with respect to topics like safety equipment, labeling, rules, and such things. Medical science applies to topics such as vision, hearing, balance, and overall health issues. Organizational psychology looks at how people work within various size groups. Organizational psychologists have made excellent contributions to the field of crew resource management, which is mandatory training for flight crews and important to maintenance crews. Educational psychologists study how people learn. Excellent training programs are often the result of using applied educational psychology. Industrial engineering is the study of humans at work, using a systematic approach to understand how people work and then to design the job and the equipment accordingly. You may be able to suggest additional human factors disciplines. Talk about the dirty dozen to your people. We all make the same kind of errors, and we are all human. To err is human. Throughout the human factors training you may hear the words dirty dozen. The dirty dozen is a listing of the 12 most common causes of human error in maintenance. The concept was developed by Mr. Gordon DuPont at Transport Canada. If we could eliminate or control these 12 causes of error, we would eliminate a very high percentage of maintenance-related events. We will look at each factor that contributes to an error and offer possible corrective actions to prevent such error. The following is a listing of the dirty dozen: lack of communication, lack of teamwork, norms, pressure, complacency, lack of knowledge, lack of awareness, lack of resources, distraction, lack of assertiveness, fatigue, stress. In your human factors training, you should remember many of these errors and learn the best methods for preventing them. Dirty dozen: the 12 most common aviation maintenance-related human factors causes of errors. Lack of communication. In general, only 30% of verbal communication is received and understood by either side in a conversation. People normally remember what was said first and last in an exchange. Consequently, it is important to put the most important part of your message first and then repeat it at the end. Depending on the complexity of the message, it might be more effective to provide some form of written instruction, such as a checklist. Norms. Norms are unwritten rules or behaviors, dictated and followed by the majority of a group. Norms can be positive and negative. A positive norm would be scanning the area inside the aircraft you have been working on prior to closing up. A negative norm would be pushing an aircraft into the hangar by yourself. Complacency, defined as self-satisfaction accompanied by a loss of awareness of the danger. If an activity has become routine and you are feeling fat, dumb, and happy, you may be missing important signals. There is a tendency to see what you expect to see. Lack of knowledge. Aviation organizations have a regulatory responsibility to ensure that their personnel have the required training. Distraction. Anything that draws your attention away from the task at hand. Psychologists say distraction is the #1 cause of forgetting things. We are always thinking ahead. Thus, we have a natural tendency, when we are distracted before returning to a job, to think we are further ahead than we actually are. Lack of teamwork. An effective team will maintain a clear mission, maintain team expectations, communicate to all team members, maintain trust,
pitch in.
Fatigue. Studies have shown that, similar to being under the influence of alcohol, we tend to underestimate the problem and overestimate our ability to cope with it. These studies have proven that after 17 hours of wakefulness, you are functioning as if you had an equivalent blood alcohol level of 0.05%. After 24 hours, the level increases to 0.1%. A very sobering thought. The more fatigued you are, the lower your IQ. It is also noteworthy that the more fatigued you are, the more easily you are distracted. Lack of awareness. Defined as a failure to recognize all the consequences of an action or lack of foresight. To combat this, try asking yourself, what if? Do I see the complete picture? What have we forgotten? Lack of resources. A lack of resources can interfere with one's ability to complete a task because there is a lack of supply and support. Low-quality products also affect one's ability to complete a task. Pressure. Urgent demands, which influence our performance, include
company,
client,
peer,
self-induced. Interestingly, people put the most pressure on themselves. Self-induced pressures are those occasions where one takes ownership of a situation, which was not of their doing. The monkey on your back is yours because you accepted it. Being assertive and not accepting the monkey will help. Lack of assertiveness. Assertiveness is the ability to express your feelings, opinions, beliefs, and needs in a positive, productive manner. It is not the same as being aggressive. The following are examples of how a lack of assertiveness can be offset. Get the person's attention and state the problem. John, I have a concern with. Give consequences if we continue. This will be the result. Give solutions. We could. You may want to try. I'd like to. Solicit feedback. What do you think? Remember to deal with one issue at a time, not multiples. Do not embellish or exaggerate. Stick to the facts and stay calm. Stress. There are two types of stress, acute and chronic. Acute stress relates to the demands placed on the body because of current issues. For example, time constraints for converting the aircraft from passenger to cargo configuration. Chronic stress results from long-term demands placed on the body by both negative and positive major life events, such as divorce or winning the lottery. Chronic stress can exaggerate the effects of acute stress. To handle acute stress, try to take a 5-minute break and relax by deep breathing. Dealing with chronic stress is more difficult and usually involves a lifestyle change. Talk about putting on the spectacles to look at the world. Sensitivity to human factors. Knowledge of how human factors affect work and safety. Objectively examine your world. Be willing to make suggestions and comments. As use case, let's see how maintenance planning address the human errors. The table shows the chance of things going wrong in a range of situations. Once circumstances become difficult, the chance that things will go wrong dramatically rises. Planning the work reduces the likelihood of problems. By developing 3T job procedures to step people through their tasks accurately, by buying the right parts and having them on hand at the job site, by deciding how to make the work safe before starting, along with the many other things that a planner does to prepare ahead of doing the job, you improve the chance of successful outcomes. We know that humans make mistakes. It makes a lot of sense to do everything possible to help people get things right first time. The slide breaks an imaginary job down into 5 tasks. The tasks form a sequential process. In a sequential process, the overall reliability is the multiplication of the individual step reliabilities. If the reliability, the chance of it working right, in one step is low, then the entire process reliability is low. When maintainers and operators do their work, they are completing a series of sequential steps. Any wrongly performed step makes the whole job wrong. This is the more reason why it is important to plan work carefully and fully and train people to do their work precisely, so that the reliability of all tasks is 100% and hence the job outcome is 100%. The slide breaks an imaginary job down into 5 tasks. The tasks form a sequential process. In a sequential process, the overall reliability is the multiplication of the individual step reliabilities. If the reliability, the chance of it working right, in one step is low, then the entire process reliability is low. When maintainers and operators do their work, they are completing a series of sequential steps. Any wrongly performed step makes the whole job wrong. This is the more reason why it is important to plan work carefully and fully, so that the reliability of all tasks is 100% and hence the job outcome is 100%. Another example of a parallel process is the carpenter's creed: measure twice, cut once. Carpenters know that the double check will save problems and trouble later. We can turn the adage into this simple parallel process shown in the figure. The typical error rate in reading a tape measure is 5 times in every 1,000 it will be misread, or 995 times out of 1,000 it will be right. A reliability of 0.995. The carpenter will cut the wood in the wrong spot about once every 200 times. It is not hard to imagine a carpenter doing 50 cuts a day. So about once a working week, they would cut the wood in the wrong place and have to throw it away. When he also does the proof test measure, the chance of getting the cut right rises to 0.9998, which is an error rate of 2 in every 10,000 times. With 50 cuts a day, they will make an error once every 100 working days, or about every 20 working weeks. The simple addition of a check test produced 20 times fewer measurement mistakes. That is the power of paralleling test activities to tasks to ensure they are right.